Hi, for the scientific method, I know that you all learned that you gotta ask a question, do some research, make a hypothesis, and then test your hypothesis with the experiment, and then analyze the data, and then you communicate your results by writing an article or making a poster or something to present at a scientific conference. That is not how science works. Science uh, uh, Different scientists approach the scientific method in different ways. We all use the same steps, but the order of the steps are very various, very diverse. So I'll give you an example. I used to work for a guy at Cal State LA who had a $3 million machine in the basement of the building, and everything that he did, he wanted to use that machine in order to justify the purchase, of course, right? And so he would start with an experiment, you know? He wouldn't necessarily start with a question. He wouldn't necessarily start with some background research. He would start with an experiment. So let me give you an example. He would find out that someone did such and such with their machine, and he would be like, huh, let me try that. And he would try the exact same thing. And then after he tried that, maybe some questions arise, and then he would ask a question. Maybe he would do some background research. You see what I mean? I guess you could argue that he started with research because he heard that someone did such and such experiment, but it is not the case that he necessarily started with a question. There is a guy by the name of George Whitesides, famous chemist at Harvard University. He has all the people working for him start with the last step. He will not do any research in his laboratory unless it is going to be important enough to publish in some scientific magazine or journal. And so he would have everyone working for him start writing the article first. They would maybe start with the introduction where they explain why the research is important, why this topic is important to humans or something, or they would start with the references where they would list the works, previous works by other scientists that are relevant to what they're trying to do, or they might even start with a title. Now, all of these things can be changed as the work goes on. They can change the title, change the introduction, change the references, but the idea is those people start with writing the articles so that they can inform their entire scientific process of inquiry from the perspective of we're going to do this in an organized manner that can be easily published so other scientists can see our work. So this order is not important. What is important is the steps. So the let me say that one more time. All these steps are important, but you do not need to follow these steps in any particular order. Very often, steps get repeated, steps are done out of order, that sort of thing. Okay, so let me guide you through a couple of salient features of, of these steps, right? So the part where you construct a hypothesis, usually the hypothesis has to be something that you can test, something that you can disprove. So you have to form your hypothesis in a way that can that in a way that it can be proved or disproved. Well, not proved, but it can be disproved. All right, it's easy to disprove something. It's very hard to prove something. And then you test your hypothesis with an experiment. So that experiment has to be carefully constructed so that it will disprove the hypothesis, or it will be unable to disprove the hypothesis. Now, the experiment has to be carefully made so that only one variable is tested at a time. So, for example, if you're trying to test a hypothesis that orange juice collects bacteria if left outside of the refrigerator, then you have to carefully make your experiment so that everything stays the same except for one variable. So if the variable is going to be out of the refrigerator, then everything else has to be the same. The same brand of orange juice is outside as it is inside. The same, the same age of orange juice is the orange juice outside is the same age as the orange juice inside. That kind of thing. The same temperature has to exist outside and inside the refrigerator. Now, if your hypothesis was orange juice collects bacteria if the temperature is higher than the temperature inside the refrigerator, well, that's different, you see. So we can only be testing one variable at a time. Everything else has to stay the same, right? All right, so the other thing about the scientific method that I wanted to make clear to you here is the difference between a theory and a law. So I have some reading for you to do about this. This is the website. There'll be some reading there, and there'll be a little quiz at the end. This reading tells you the difference between a theory and a law. And in the quiz at the end, it can be redone as many times as you want, and then I have reproduced those same questions right here so that you can get all these questions right, so that you know what the difference is between a theory and a law. Now, when we say theory in science, usually we're not talking about the theory that you talk about with your friends. For example, yeah, I have a theory that there are mice in my apartment, and that is why my dog goes nuts at night. That is my theory. Yeah. So you have no idea, actually. So that is just your vague idea. That's not what we're talking about in science. Theory in science is the result of bunch of experiments repeated by many different people all over the world, so much so that it becomes obvious, it becomes a matter of course to the scientific community that your explanation for something is the correct explanation, or your model for the way something in nature works is true. So we're pretty sure that a scientific theory is right. We are not 100% sure. We do not know that it is right, because 1,000 years from now, with better technology, presumably, we may correct your theory. So that's what science is all about. Making some discovery, it soon becomes a theory. People argue over it, and then later it is overturned and it is improved upon, and that's how science proceeds. There are no actual absolute truths in science, because tomorrow, we could discover something totally different that fits the data much better. Anyways. Now, a law is not like a theory. A theory is an explanation that has been tested by many different people and has been generally accepted to be true. Right? So a law is not like that. A law is not an explanation at all. A law, so I'm doing nothing with the screen, I'm just talking. A law is, it says on this website what a law is, but I'll just tell you briefly since you're paying me. A law is an observation about nature that cannot be proved or disproved. It's just a fact of nature. For example, the law of gravity. What goes up must come down on a given planet. So can you prove that that will always happen? That would be very hard to do. I do not believe that you can prove that that will always happen. You can just keep on doing that, keep on dropping apples forever, but it's very hard to prove that that's always going to happen. But anyways, the law of gravity is the description of nature. Stuff falls on this planet. And very often the description takes the form of an equation. For example, just to use the video a little bit, the law of gravity has an equation. Oh my gosh, where's the equation? The law of gravity has an equation. Newton's second law of motion has an equation. So laws very often have equations. Not always, but they often do. Because laws are just descriptions of how nature behaves, not explanations. There's no explanation in the law of gravity of why nature behaves this way. There's no explanation. Now, Einstein's theory, one of Einstein's theories of relativity, has an explanation of why gravity behaves this way, right? Now, that is not a law. That is a theory. It is an explanation that is generally accepted to be true for now. And so that's the difference. And that's all. Thank you.